Hello, this video is about the basics of nephron function. Nephrons are the functional unit of the kidney. Your kidneys are two excretory organs that are in your retroperitoneal cavity, and their job is to get rid of waste, not every type of waste, but water-soluble wastes, and to do so without losing too much water. They help to maintain water balance and also salt balance and get rid of wastes from your blood. The kidneys themselves, you usually have two of them, are drained with tubes called ureters into the bladder and then out the urethra. The kidneys have an outer region called the cortex, and the cortex is what I'm coloring here in black, and they have these inner regions called medulla. Sometimes they're called pyramids, and sometimes they're called renal medulla. There is this kind of funnel which is collecting the drops of urine, and that's called the renal pelvis, which is going to direct that urine into the ureter, and the ureter will drain it to the bladder with a combination of just gravity and peristalsis. The nephrons themselves make a dip from the cortex down into the medulla and back up before they're finally drained by a collecting duct into the renal pelvis. So the nephrons themselves have a small tube, and that tube has different regions, and they are, of course, surrounded by capillaries. The general idea of the nephron is that we have a filter that filters by size. The glomerulus filters by size. We then have some reabsorption, taking stuff back into our blood. It made it through the filter, but we still want it. Good stuff like sugar, amino acids. We want that stuff. That's called reabsorption. It's called tubular reabsorption because it happens in this tube called the nephron. There's also secretion where we take additional wastes out of the blood. And at the very end, in the collecting duct, we have our last chance to reabsorb water before we make the urine. The different structures of the nephron are represented in different diagrams. Here's a diagram showing the different structures of the nephron surrounded by capillaries, blood vessels. The blood vessels I've labeled in purple, and the nephron structures I've labeled in black. There are some different ways to illustrate this, ways that show how surrounded by blood vessels your nephrons can be, often make the diagram pretty messy. So usually those get eliminated from the diagram. They're there in real life, but they're not there in the diagram. Your diagram is more likely to look something like this. Not like the one on the side, which shows the true kind of scale of how skinny and how far down and up these go into the medulla and back into the cortex, but rather like this part here that shows we start with the Bowman's capsule. The Bowman's capsule has a blood vessel inside it. The blood vessel inside it is getting blood from an artery, arteriole, called the afferent arteriole. The blood is coming through under high-ish pressure, and it's leaving through the efferent arteriole. Some stuff is going to leak out of there, and the stuff that leaks out is called filtrate. The filtrate, pick a good color here, nice urine-y color. It has to show up though. How about if I just do blue? Blue isn't a good urine color, but it shows up well. That filtrate will travel first through this region called the proximal tubule, or sometimes proximal convoluted tubule. Convoluted just means twisty and turny. We know why things are twisty and turny in biology. To increase surface area. The proximal tubule has one main goal, which is to reabsorb good stuff that not accidentally, but accidentally made it through the glomerulus. So reabsorb some water, some sugar, reabsorb some amino acids, all that good stuff. The next section is called the descending limb of the loop of Henle, and the descending limb of the loop of Henle will let water come out, but not salt. It's permeable to water, but not permeable to salt. On the way back up, especially as we get to this thicker walled part, we are on the ascending limb of the loop of Henle, where water cannot come out, but things like sodium ions or chloride ions do get pumped out. Sodium ions get pumped out directly. This is to set up a concept called countercurrent multiplication I'll talk about in a minute. This helps to make it easier to conserve water. This is all happening down in the medulla. Everything below about this line is in the medulla. And the medulla is really salty. Salty with salt and salty with urine. Either way, it has a high draw on water. It's really good at drawing water in close. Next, we go to the distal. Distal means far away, proximal means close to the beginning. Uh, distal convoluted tubule, and the job of the distal convoluted tubule is mostly to balance ion concentrations, things like sodium, potassium, and pH, regulating the acidity of your urine and therefore your blood. At the end, the filtrate will flow into the collecting duct, which collects urine, or almost urine, from many nephrons. The collecting duct has tiny little holes in it called aquaporins that can open up in the presence of the hormone ADH, antidiuretic hormone, and allow water to come back out into this salty medulla tissue and be reabsorbed into the blood. So we've got fluid, this is just an illustration stolen from that crash course, flowing through our proximal tubule, descending loop of Henle, ascending loop of Henle, distal tubule, and then the collecting duct. Inside of the structures, we first reach the glomerulus, which isn't part of the nephron, but it's inside of the Bowman's capsule. Bowman's capsule just catches what the glomerulus squeezes through. Inside of the afferent arteriole is normal blood. It comes through here and the glomerulus has tiny little holes in it, and it allows water, ions, sugar, all that good stuff through, but not big things like no erythrocytes, no red blood cells can come through. No big proteins. Some small proteins can come through, but we're going to say no proteins for now. No white blood cells can come through either, no leukocytes. No platelets can come through. If any of those things come through, that means that there's a problem with your glomerulus. It's been ripped or damaged, probably due to high pressure, maybe because of an impact. So the glomerulus acts like a physical filter, only letting small stuff through. That small stuff would have been called plasma a moment ago when it was in your blood, but now that it's in your nephron, we call it filtrate, that which has been filtered. Your proximal tubule is very twisty. The cells lining your proximal tubule have lots of microvilli, lots of mitochondria, and the tube itself is very twisty, not very straight. All of those things are just like your small intestine, especially this last two sections of your small intestine, the jejunum or the ileum. And I don't know why I did it with an I there. The jejunum and the ileum are that way, twisty and turny with lots of mitochondria and lots of microvilli, so that we can have lots of good absorption. This is not just absorption because you had it in your blood already, but reabsorption of, there's lots of things, but I want you to concentrate on sugar, especially glucose, our favorite sugar, and amino acids. Lots of sodium and water gets reabsorbed here too, but focus on these guys. The downward and upward parts of your loop of Henle are, again, I said different. On the way down, water is coming out. It's permeable to water, which makes the filtrate more concentrated. On the way back up, we're pumping sodium out. Some other ions come along too. And that makes the medulla, because everything down here is medulla and cortex up here, the medulla tissue more salty, which pulls more water out the next time filter comes through, which is constantly happening. So that saltiness in the medulla is increased by pumping out lots of salt, and that helps to draw out lots of water from future bits of filtrate. This is called a countercurrent multiplier, and there's lots more to learn about it, although we won't test you on it in Bio 20. But it's a cool concept, a good way that your body is regulating its water levels. So make sure you study. This is just salt crystals forming, an actual video of salt crystals forming under a microscope, an electron microscope. Make sure you study these structures, make sure you know what all the parts do, and you ask questions if you're not sure.